Okay, welcome back. Thanks. We took a few extra minutes just to get things in order here. We're here for our last question and answer period, and outside you saw just briefly there a beautiful view outside the windows here at Breckenridge. Temperatures getting into the low 30s now. So on my left, your right, Dr. Peter Gleick, who just spoke from the Pacific Institute, and on my right, your left, watching online, is Paul Kocin, who is a forecaster at NOAA's National Weather Service Weather Prediction Center. So we're going to open up the question and answer period now, and I know that Sarah Perfader, our social media producer and meteorologist, has some questions that she has received online. Sarah.
Okay, hi guys. So the first question is for Paul. Snow maps with discrete contours are misleadingly precise, but public doesn't understand the probabilities. Any ideas on how to communicate risk graphically? And by risk, I mean forecast uncertainty.
That actually is the question of the day. We're working on that. I think that's the part of the problem that we haven't got solved yet. So to be able to go from the what's called deterministic forecasts to these probabilistic forecasts, we have to come up with a better mousetrap, and I really can't offer what that solution is quite yet. I wish I could. I think there are a lot of people working on that, but I think that's really one of the challenges we still face.
Could I offer a comment on that? This is a great question, and when I was listening to Paul's talk, I was thinking, the truth is what people really want to know is not necessarily whether it's going to be 1 inch or 2 inch, but is my school going to be closed, or is there going to be a problem with getting to work, or the social risks?
We call them impacts.
And I like the idea of making it clear, look, we're doing the best we can from a projection point of view, but what you really want to know is the following. And we do know it's going to snow, and we do know you ought to take the following kinds of precautions. And that's a risk communication question, and I think the TV meteorologists are making enormous progress at that, and that's maybe where part of the conversation could go.
That's great. So as a follow-up, this person who asked the question has a suggestion. So it said, what about continuously shaded contours instead of line boundaries or overlapping ranges, 1 to 3, 2 to 4, 3 to 6, etc.? Could you comment on that suggestion?
Well, I think suggestions like that are good, and you have to understand actually that those line drawings that I presented are not the ones that are being presented to the public. As a matter of fact, the Weather Service is still going out with more, not just probabilistic diagrams, but just what are the odds of, say, a 2 to 4 inch snowfall, a 4 to 8 inch snowfall, something greater than 20 inches or something like that. That can be expressed as like a 95th percentile chance we have. That's way out there versus a 50% chance it'll be in this sort of range to a lower percentage than that. So that kind of thing is already being instituted.
Great. So this next question is for Peter Gleick. You had a graph up showing California temperatures and precipitation anomalies in a 4-quadrant type graph. So the question was, what are the quadrant breakdowns, meaning how many years are in each quadrant?
Oh, that's a great question. I don't really know the answer to that. I'd have to go back and look and count. But another part of that question is, if you separate them by decades, are decades appearing in certain kinds of quadrants? And it turns out the most recent decades have really been in the hot, dry quadrant, the upper right quadrant of that graph, far more than, say, years from the beginning of the 1900s, which were cooler and more average wet. So we're beginning to see not just more hotter, drier, but more clustering of recent years.
Great, and also pertaining to that graph, of the years in the 21st century, where are those years located on this graph?
Yes, so that's related to this question. More and more of them in the last 15 years, the last decade and a half of the 21st century, are in that upper left-hand quadrant, that hot, dry quadrant. We've had, it's not just 3 years of drought now. I think of the last 14 years, 10 of them have been abnormally dry, and almost all of them have been abnormally warm as well.
Thank you. Okay, this one we're going back to Paul Kocin. When issuing snow maps, how much do you take into consideration the current status of the teleconnections, the Arctic Oscillation, North Atlantic Oscillation, and Pacific North American pattern?
I think when we're always issuing that, that's in the back of our minds, but when it comes to specific forecasts that we're doing really just a few days in advance, those kind of issues I think can sort of get in the way, in that they may indicate sort of the general background conditions, but even within those background conditions, even when they're not favorable, that doesn't guarantee that a specific, if for example, we like a negative NAO if we're going to forecast snowfall, but not every big snowstorm occurs with a negative NAO. So they're in our minds, but they really don't come into play when we actually, when the rubber hits the road.
Okay, and this, you'll be glad to know this is the last question, and this one is for Peter. Are there negative effects to stormwater harvesting? Meaning, if people start harvesting stormwater on a large scale, does that negatively impact a community's ability to supply water?
We are increasingly looking in the western U.S. and other parts of the world at stormwater harvesting, that is, capturing stormwater, these rapid, intense events, and figuring a way to store that water rather than let it run out into the ocean. We do have to be careful about water quality issues. There are often, with intense runoff events, concerns about water quality contamination. We have to worry about ecosystems as well. Sometimes storm water is really important, for example, at getting fish to move out of rivers into the oceans, like salmon. And so there's questions about that. Like any water management technique, I guess the best way I can respond to this question is to say, you look at the advantages, you look at the disadvantages, you look at water management, and figure out a best way to accomplish what you want to accomplish without causing other problems.
Great. Are there any other questions in the room?
There's one other question here that was texted to me, Peter, during your talk, and that was, could you comment on the recent rain event in California and how that has either helped the drought, done away with the drought, so is everybody okay, or is it just a drop in the bucket?
We had a very big rain event in December. We had an atmospheric river. It delivered a substantial amount of water to California. The good news is it was better than getting nothing in December. The bad news is it by no means has eliminated the drought. And in fact, if you look at the statistics today, average rainfall in California for the current rainy season is below normal. We're not, even with the December storms, we haven't gotten much water. Our snowpack is less than half of normal. And unfortunately, there was a sort of a social dynamic to that as well. It rained a lot in December, and a lot of people thought, well, the drought's over. I don't have to conserve anymore. I don't have to do any more. The drought's not over. We need a tremendous amount of rain, even to get us back to normal in California, much less to recharge both our soil moisture deficit and our reservoir deficit. The drought's continuing, unfortunately.
Okay, and I have had a follow-up clarification for the stormwater question. It says it was more in reference to the use in domestic irrigation, think rainwater barrels. Thoughts on that?
So there is another piece of this puzzle is people are beginning to install rainwater capture on their homes. When it rains, instead of letting that water run off to the system, they capture some in rain barrels or other storage facilities on their property, and then use that water during dry periods. That's good for certain kinds of climate. It's not great for California because we have a rainy season, then we have a very long dry season, and you can't really store enough water in rain barrels in a home, for example, to get you through really more than a week or two of our long dry season. So it's a contributing solution. It's a things that we can look at in certain kinds of climates, certain kinds of weather conditions, but we have to implement the right thing in the right place at the right time.
And I just want you both to know that the online audience is thanking you profusely for answering their questions. It's very exciting for them to hear them on the air.
Well, thanks. It's great to be able to interact in this way.
Well, this is terrific. Thank you guys very much. This is a really unique opportunity for online viewers to ask questions directly of the speakers, which is pretty awesome. I do want to remind the online viewers as well that we do put the presentations, the PDF versions of the PowerPoint presentations. We also put the videos that were streamed live on the website. The website you can go to is www.stormcenter.com. www.wxc summit. And then you can go to the videos tab and see those. So we're processing those videos right now, and they'll be all online likely by tomorrow afternoon, if not by Monday morning. I believe that day 1 and day 2 sessions are being posted. Day 1 is already up and online. So thank you both very much for joining us this morning. Thank you online viewers for joining us all week. We had tremendous viewership. We had great viewers also from international locations. And thanks for participating in the back and forth question and answer period. Our town hall meeting last night was tremendous. We had a full room here in Breckenridge at the Doubletree Hotel. We also had a full room at Old Dominion University, watching live, talking about sea level rise and its impacts. So thanks very much again, and we appreciate you watching the Glenn Gerberg Weather and Climate Summit. And until next year, we bid you farewell. Thank you very much for watching.